The diagram shows a sector AOB of a circle with center O and radius 5 centimeters. Angle AOB is theta radians. The area of the triangle AOB is 8 centimeters squared. Given that the angle theta is obtuse, find theta. The shaded segment in the diagram is bound by the chord AB and the arc AB. Find the area of the segment, giving your answer correct to 3 significant figures. Find the perimeter of the segment, giving your answer to correct to 3 significant figures. So I think I've got everything here. Right, the only thing I didn't have, the area was 8 centimeters, this was 5 centimeters here. I think that was it. Just have one little check on the question paper. The area of triangle is 8 centimeters squared, AOB. That's what I needed to put. So this area here isn't the area in question. That's the area of the shaded segment. But this area here, 8 centimeters squared. Okay, good. That's everything then. So given theta is obtuse, so the area of this triangle then, part 1, area, is equal to half BC sine A, isn't it? Half this times sine of the included angle. So half of a 5 times another 5, because they're both radii, times the sine of the included angle. That is equal to 8, as we're told. So here we know that now sine theta is equal to, well, the 2 can come up to be with the 8 to make 16. The 5 times 5 is 25. We move that from times down to divide. So that tells us what theta is, doesn't it? So do shift sine. The only thing with this then, don't forget that sine is positive and it's between 0 and 180. So sine alpha is what we're going to do when we do shift sine here. But we need the obtuse value. So here sine alpha, let's write it down, is 16 over 25. So now we can write down alpha. So let's make sure we do that. So shift sine 16 over 25. So shift sine 16 divided by 25 equals 39.79, 39.8. 39.8. So that tells us that theta, which is around to here, isn't it, the obtuse angle, 180 minus 39.8 degrees is 140.2 degrees. There's theta then, and that's the obtuse angle there. Find the shaded area to 3 significant figures. So the shaded area, well, it's a segment of a circle, isn't it? So part 2. Now the formula for the segment of a circle, the area of a whole circle is equal to pi r squared. But if you want to write that as a fraction of 2 pi, you'd have to put a 2 there and a 2 there, wouldn't you? So this gives us the area of a whole circle in terms of the radians of a full circle. So that helps us to remember what the area of a sector is. So area of a sector is not 2 pi, but is the actual angle. So it's r squared, half r squared theta, isn't it? There's the formula that is discernible from this simple fact. So half r squared theta. Find the shaded area to 3 significant figures. So the total area is that. So now we've got that's equal to a half. R is 5, so that's 5 squared. Times theta, we need theta in radians. So I've got it in my calculator here as that. So if I do shift mode and do radians now, number 4, we'll get 0.6945. 6945? 0.6945 radians. That was alpha. So that it's pi minus. Okay, that's what we've got for theta there in terms of the radians. So let's put that down then, because we seem to be working in radians, don't we? So let's make sure we do that then. So it's shift pi minus 0.6945 equals 2.447. So I'm going to leave it at nice and accurate. 2.447 dot dot dot. So there's our theta in radians. Okay, so the area of the sector then will be half 5 squared times this 2.447 radians. So if I now keep that in the calculator, I can then times it, divide it by 2, and times it by 25. 5 squared is 25. 30.58. And now I can round to 3 significant figures. 30.6. And that would be centimeters squared. That's the area of the sector. Okay, so the area of the triangle, we could work out here, but we know it's 8. So the area of the shaded segment then. So answer, the area of the shaded segment is equal to the total area of the sector minus the area of the triangle, which is 8, and it leaves 22.6 centimeters squared. So that's that one. Find the perimeter of the shaded segment. Now the perimeter would consist of this distance here, this arc length, plus this length here. Okay, so let's get arc length first. So part 3, the arc length, the arc AB in other words, is equal to, now the circumference of a circle is 2 pi r. So you can see that it's 2 pi times the radius, so the arc length is simply r theta, if we can discern it from this simple formula that we always know anyways. And we can remember that the arc length is r theta, so that would be, the radius is 5. Theta is the 2.447, isn't it? Which equals, so let's get the calculator then. 5 times 2.447 equals 12.235, 12.2. And that was to the 3 significant figures. So that's that length, and that's in centimeters. Now that's the arc length. Now the perimeter of the shade also needs to include this length here. And if we labelled that as, we'll have to call it O, I suppose, little o, and use the cosine rule. Yeah, use the cosine rule. So O squared is equal to the other two sides squared, which is 5 squared plus 5 squared, minus 2 times the other two sides squared, which is 5 times 5, of course. Cosine of the angle theta, isn't it? The included angle. So 25 plus 25 is 50. 2 25s are also 50. Cosine of the included angle. Cosine theta. And the angle of theta is 2.447. So let's type that in the calculator then. So we've got 50 minus 50 times, times cosine cos, we're in radians mode, 2.447. I hope this is going to be accurate enough. Close the bracket, equals that, so that's equal to, so that was 88.4, what was it, 17? Was it 415? And then, since I pressed answer, that's the 88. So if I do square root now of the answer equals 9.40. So to 3 significant figures, it's 9.40. 9.40. Well, I'm not going to do 3 significant figures at the moment because I need the square root. So let's, oh, we have square rooted. So it is 9.40 then. That's fine. So we get that. So that's that. And that would be centimeters. And that's the 3 significant figures. So, answer for the actual question would be the arc length, 12.2, plus the 9.40 is equal to 21.6 centimeters, and that's the 3 significant figures.